Hi everyone. Today we're going to look at a beginning of lesson 8.2, graphs of polar equations. We're looking at some of the more basic examples and the ones that are kind of easier to graph. And we're going to start with the most basic one, graphing a line. So let's take a look at that example. A line would be given when you have a theta equaling a value. So theta equals pi over 3 or theta equals some radian measure. And it will just graph as a line along that radian measure, the line that represents it. Now notice this is the general graph paper when we're graphing a polar equation. It's a little different than graphing a point. Technically you could use it when graphing a point, but we usually don't. Around the outside you have your radian measures. And then these circles represent the R values. So if R is 0, you would be here at the pole. And then this is R is 1, 2, 3, 4, or 5. And you can have decimal values for R in between these. And that's okay. You would just estimate where it is. So in my example, I've been asked to graph theta equals pi over 3. So all I would do is find pi over 3 around the outside, and I would graph a straight line along this pi over 3 value. And it would go all the way to the other side, the 4 pi over 3 side as well. So I would just graph that line that would look like this, and then my graph is finished. So all I would do is just highlight this pi over 3 line. Okay. The next graph we have is the graph of a circle that's centered at the pole. Again, this one's going to be a very basic graph. It's generally given as R equals a value, and it just graphs as a circle on that value. So like R equals 3 would graph as a circle right here at 3. So I'd count out 3 circles, and then I highlight this circle. And I would just go all the way around like this. And that is my graph. Anytime you have just R equals a number, it graphs as a circle. Anytime you have theta equals a number, it graphs as a line. Now, there are ways to get other graphs, and the first way that we're going to talk about is using a table of values. So in a table of values, you're going to choose values for theta, and then use the expression that they give to find the R values. And you want to be careful to connect these in order, because otherwise your graph will not look correct. And then you also want to find at least 2 values in each quadrant. And I always like to use the axis values like 0, pi over 2, pi, 3 pi over 2, and then 2 in each quadrant. I find that that gives me a very good graph of whatever it is that I'm trying to graph. So let me show you an example of what that would look like. So I've been asked to graph y equals 2 sine theta. And I've started a table of values. I'm going to pick theta values. I'll do 2 times the sine of that theta value, and then I'm going to get the R. So I'm going to pick 0. I'm going to skip this one and do pi over 6. I'll skip this one and do pi over 3. I'll skip this one and do pi over 2, and I'll do that all the way around. Now, technically, you're allowed to pick any values that you want. I would definitely recommend staying with ones that are on your unit circle, so like pi over 6, pi over 4, pi over 3, and pick ones that are easiest to calculate with. So all I'm going to do is just fill in my table, and I'm going to start with just 0 to pi, and then I'll do pi to pi over 2 later, but I'll just start with 0 to pi. So I picked 0, I put it into sine of 0, which is 0, and then I did 2 times that. For pi over 6, I did sine of pi over 6, and I got this from a unit circle. It is 1/2. Then I did 2 times 1/2 is 1. And I did that for all of these. Sine at pi over 3 is square root 3 over 2 on my unit circle, and then times 2 got me 1.7. Now, I did do the square root, and I rounded it to 1 decimal place, because that's about all you can estimate on these graphs anyway. And we would want to know what the square root of 3 is approximately equal to. So I'm going to take these points and put them on my graph. I'll start with 0 and 0 and 1 at pi over 6. So I'll put those on there and connect them with a curve, and that gets me this lovely curve right here. Now, we estimate the curve. It's not always going to be exact. And then we can clean up the curve later. So you'll notice that the curve isn't looking exactly wonderful at the beginning, but later on I'm going to clean it up. So now I'm going to put on this pi over 3 point. So I go 1.7 out on the pi over 3 line. So here's pi over 3, and I go one circle and then like 0.7. So one circle and like a little more than half. And it would graph like this. Now I did adjust that other line to make it look a little better, but I'm going to do a little more adjusting in a minute when I put on the pi over 2 point with 2. At pi over 2 and 2, I get this, and it's now showing a nice little curve here. And I'm just going to put on the rest of these points, 2 pi over 3, 5 pi over 6, and pi. Now notice pi connects back to 0, and that is okay. You are allowed to connect back to 0. Just follow the points in whatever order, and if you connect back to a point that you've already used, that's fine. So here's what my graph is starting to look like. Now this looks like an off-center circle, but I really should check the other values that I skipped. So I didn't do 7 pi over 6, 4 pi over 3, all these bottom values. So I'm going to check those and make sure they don't add anything important to my graph. So when I did 7 pi over 6, I got -1. When I graph that, I would go along this line, and then I would go one circle backwards. So that ends up right where this point was at pi over 6. And then 4 pi over 3, that works the same way. I would go -1.7, and that's this point I already have. And then 3 pi over 2 would be here because it's -2. So all of those points are points that I already have. So this is my final graph. Now, I hope that was a good explanation of how to use a table to graph a function in polar form. Let me know if you have any questions or if you need help with anything.